A standard low-speed fan is a device that circulates air using rotational blade at a low angular velocity to reduce energy consumption. Based on rotational mechanics, its operation depends on the relationship between torque, angular velocity, and the blade radius to generate airflow. From the perspective of thermophysics, the fan enhances cooling through force, convecting allow the heat and dissipate from effectively. However, a non-optimized low-speed fan may experience energy loss and heat buildup due to efficient airflow and friction. In this presentation, we will explain the improvement of a low-speed fan by applying concepts from rotational mechanics and thermophysics, which are covered in Physics 210. Problem with the existing products. First, we look at the standard low-speed fan. Although this type of fan consumes a low energy, it often produces weak airflow and inefficient cooling, especially when used for a long period of time. In addition, heat tends to accumulate around the motor, reducing the fan's overall efficiency. So, for proposed improvement, to overcome this problem, we propose an innovative low-speed fan with dual-layer blades. This design consists of an outer blade for airflow and an inner blade for stability, allowing the fan to perform better even at low rotational speed. Alright, for key needs. The key needs we address is the need for comfortable and quiet cooling. Many users do not require strong airflow, but instead need a fan that can operate at low speed, consume less energy, and provide continuous comfort without disturbance.
On this slide, we focus on who really needs this solution and why, along with real-life examples. First, students and individuals with personal comfort needs. Students need cooling that is affordable, quiet, and energy efficient, especially for long daily use while studying or attending online classes. Most students face challenges like a limited budget, small rooms, long hours indoors, and sometimes shared or restricted electricity usage. Because of this, low-speed fans are ideal as they provide steady airflow without high energy costs or noise. Common examples include rented rooms, hostels, classrooms. Next, commercial buildings and offices. These spaces focus on reducing air conditioning load, improving thermal comfort in large areas, and lowering operational costs. Low-speed fans help by promoting better air circulation and even temperature distribution, which allow air conditioners to be set at higher temperatures, saving energy. They also operate quietly, making them suitable for work and meetings. Examples include open-plan offices, shopping malls, schools, universities, mosques, and community halls. For overall, this shows that low-speed fans meet the needs of both individual and large organizations by balancing comfort, efficiency, and cost savings. For this part, it shows how often and when the problem occurs. For students, it happens daily, especially during long study hours, in the afternoon and at night, during online classes, and even while sleeping in hot weather. It's frequent because students spend long hours indoors. Small rooms trap heat and fans are used continuously. For commercial buildings and offices, the problem occurs every day during operating hours, mainly from 8 a.m. to 6 p.m. and during peak occupancy. Large spaces, high occupancy, and continuous equipment use cause heat build-up. And this is a daily and ongoing issues, making efficient cooling solutions essential.
For the fourth question, the problem is actually quite big for users. Most conventional fans use electricity continuously at a fixed speed, even when full cooling is not even necessary. For example, students at dorms or families at home often leave the fan running for many hours, especially at night. This causes energy waste and also increases the monthly electricity bill. Over time, this has become a financial burden, especially for students and also some low-income households. In the long term, high energy usage can also increase maintenance costs and reduce the lifespan of the fan itself. For the fifth question, if this need is not met, users will continuously facing the same problem over and over again. So they will have to keep paying high electricity bills due to inefficient cooling systems. At the same time, excessive energy usage contributes to environmental issues such as increased carbon emissions. Some users may try to reduce fan usage to save money, but this will lead to thermal discomfort, especially in hot and humid climates like in Malaysia. Therefore, without an energy-efficient solution like the smart cooling fan, both users and the environmental will be negatively affected.
Firstly, the purpose solution focus on achieving effective cooling at lower rotational speed by optimizing the blade's geometry and airflow pattern of the fan. Instead of increasing speed to enhance cooling, this approach improves cooling efficiency through better airflow management and reduce energy loss. Next, our solution focuses on improving airflow efficiency rather than increasing fan speed. The fan is designed with optimized blades that reduce air resistance and turbulence, allowing air to flow more smoothly. Because of this, effective cooling can be achieved at a lower rotational speed. This reduces the torque and power required by the motor, resulting in lower energy consumption. At the same time, the smoother airflow enhances convective heat transfer, allowing heat to be removed more efficiently from the surrounding air. There are several technical issues that need to be addressed in this design. First, the fan must remain stable when operating at lower rotational speed to avoid vibration and uneven airflow. This requires proper blades balance and accurate alignment to ensure smooth and consistent rotation. Second, the fan needs to maintain adequate airflow without increasing motor power. This is achieved by optimizing the blade shape and airflow direction to reduce air resistance and energy loss. The thirdly, which is the finally, the design must balance cooling performance with energy efficiency. The fan should provide noticeable cooling while minimizing electrical energy consumption to ensure user comfort without unnecessary power usage.